Hello everyone, today we will be learning about a new chapter, vector calculus. As its name says, it's study about the vector. Vector is very important as you know that it deals with directions, and without direction it's quite difficult to represent any quantity. Like for example, if you will say the navigation of ship or even the planes, they all need direction. Like even if specifically if you have to take any example, like in the army, if they are launching in any explosive, they need to know the direction first of all, like how much impact it's going to create and how much distance direction it should be there. So it's very important thing, direction of any quantity. So the study of that vector, that is nothing but a vector calculus. Specifically in vector calculus, we do differentiation and integration of vector field. What is vector field is, vector field is nothing but it represents magnitude, it represents any physical quantity at particular point. Like for example, it's a force, any force like gravitational force or electromagnetism. At particular point it gets represented by vector field. So in this particularly in vector calculus, we study about the differentiation and integration of this vector field. So I have listed here the topics which are included in the vector calculus. So first of all, we will be learning about what is vector calculus, then application of vector calculus, then what is directional derivative, then curl and divergence of vector, then curl of vector field, then types of vector integral. First of all, we will see what is a vector integral and then its types, then Green's theorems, those are Stokes theorems, those are also important theorems, and Gauss divergence theorem. As we will go to the particular topic, then we will discuss more about it in more detail with example. So right now here I have listed just the topics which we will be looking throughout this chapter. So first of all, let's see what is vector calculus. So as I said, like when we say about vector calculus, it's a vector which we will be studying about the vector. So first of all, I have listed what is any given quantity. You have studied this scalar and vector. We differentiate between this. Scalar means any quantity which doesn't need any direction to specify to represent it. For example, we say that I have taken here example like mass and density or displacement. So these are the quantities where we don't need to specify the direction, only magnitude. If you represent it, that's more than enough to represent it. But whenever we say the vector quantity, we need to specify the direction of it, so that it becomes meaningful, or it makes some sense. Like for example, force or a force. Like for example, if I am measuring the length, any scalar quantity, if I will take example of scalar quantity, if we want to measure the length of any pen, then it doesn't matter which direction you measure it, it's not going to make any difference. The length of the pen, it is going to be the same. So that direction is not required. Here in the vector, like for example, if you want to open the door of your room, so it depends on which direction you are pulling it or applying the force. Depending on that, it will open or it will not open. So here the magnitude as well as the direction, both are important. So that is vector. So we know all this. So here in this particular topic, we will be learning about the vector specific and vector field and its integration and differentiation. Now first the important thing is where we are going to apply it, because this concept where we will be applying it here. So I have listed here this few of the applications over here. So in the fluid dynamics, electrodynamics, general relativity and quantum mechanics and computer graphics, these are the few of the application I have put it over here. Like let's say if I will take example of this computer graphics, we can say like whatever we are looking on the screen, that's nothing but the information, whatever we are want to visualize, want to see on the screen, that is in the form of pixels we are entering or feeding into the computer. So, those a pixel carries the information in the form of like a vector, like a color, brightness and all these things. So, vector, it plays important role in the computer graphics as well as. Then specifically, then again if you want to discuss like these fluid dynamics. So, particularly like if any fluid is there, so in like how much it's more like how much its a flow is and how much it's what is its direction, that we will be looking more in detail when we will be learning about divergence and curl of the vector, because that more we will be we will understand how it gets applied over there. So, right now I have just listed here, it's gets applied in fluid dynamics and all these fields. So, it's very important topic or chapter in the real life also, because it gets applied almost everywhere. Now, let us move to the next point, which is position vector. So, what is position vector is like if you want to know the position or the location of any point with respect to any reference point, then we call it like a position vector. For example, I will just draw it here, xy plane, xyz, let us say here. So, if I want to take, I have taken this P as a point, any point, then how we will tell where the P point is located. If you want to specifically tell what is its location, then how we are going to how you are going to represent it, how you are going to tell it, that then how we measure it, we take origin as a reference point, and with reference to origin we tell where it is located. Like for example, x axis, the distance along the x axis becomes its x coordinate, and the distance along the y axis, it becomes its y coordinate and z coordinate. So, something like that, but with reference to origin we measure that. So, that is nothing but the position vector, means position vector. So, what we can, as if you want to define it, how we define it, at a position vector is a vector that symbolize the either position or location of any given point with respect to any arbitrary reference point like origin. So, with reference to any reference point, we tell the position of the any point. So, that is nothing but the position vector, and it is used to specify the position of any certain body. So, because it is quite important to find the location of any specific body in the space or in 3 dimensional also, or even in 2 dimension also. That is why we need it, position vector. So, now we learn about what position vector is. So, in mathematically how we represent the position vector is normally we use the symbol capital R, and we use small r also, but most of the time in many books it gets represented by small r, and on top of it that vector sign is there. So, but capital R also gets used. So, nothing wrong in that. So, here how we represent is xi plus yj plus zk. If you see here, there is small cap over there on top of I, j and k. So, how we pronounce it is as a I cap, j cap and k cap. So, r vector is nothing but the position vector, and how we represent it is x I cap plus y j cap plus z k cap. So, this is quite important because we will be using it almost everywhere throughout the chapter. So, where I cap, j cap and k cap are unit vectors in the direction of x, y and z axis respectively. So, now if you want to, this is about how we represent it, but if you want to find its magnitude, so the formula which we will be using it is under root of x square plus y square plus z square. That is nothing but the small r, it is a when since it's a magnitude, so we don't put arrow on its head on top of it, because it's a purely, it doesn't need any direction. So it's a magnitude. This formula is also important because we will be using this further. So remember that this is to find magnitude, and since it's a magnitude, we put it in the this sign to represent its magnitude. So both the formulas, like how to represent it, position vector, that is important, as well as how to find the magnitude, that formula, both are important. Let's discuss in more details in next video.